This is my gravitational field model. It is an account for electron quantum field interference to explain how gravity is not necessarily a warping of space-time in a conically shaped pattern, which always kind of confused me and frustrated me. It is it's more of a averaged out field impulse of the electron atmosphere, so quantum atmospheres. I was watching a video of noodles, and the dry spaghetti noodle is what sparked this, that if you take the dry spaghetti noodle and you compress it, it'll form a sort of wave pattern before it breaks into 3 pieces consistently. And people are kind of confused about why that worked. And it dawned on me, well, if we have different densities of the electron field, as we all know, that only we take an electron charge and that is kept at certain distances away from the nuclei, and it can only accumulate per charge per ring on the periodic table. Well, it's not necessarily what is happening, and this was my attempt at explaining interference patterns and gravity, to explain how it averages out, why we have weak and strong force in the old physics sense, and why we have momentum at all. Because if you study a little bit of relativity equals mc squared, well, if you apply force or energy to mass, velocity goes down. So, or what am I saying here? That mass increases through energy. So every time you would push on an object, it should, in theory, get heavier and push back on you. No matter how much force you apply, an object should stay there. Why do we have acceleration and momentum and all this other stuff? And so this is explaining how two encountering particles with fields and field charges and orbitals, basically quantum atmospheres, equate their distance to balance out a charge, and that results in mass. And we can look at the distance of these encountering circumferences and draw a wave around it to not only mimic gravity, as Einstein sort of explained it as a warping space-time, and it's a cone and all this other stuff, and it's just like, yes, to me that's not making any sense. So through quantum interference, you have a shifting field, and I do my best to draw out all these ideas and how a field emitted creates, through acceleration, a warping field forwards and backwards, but also the density of the different radii from the center of the charge. And since this is moving this way, the electrons are going to want to pulse, because if there's zero velocity and you just look at a particle, the electrons don't necessarily want to move. They're kind of stable. And so So you can see here how one field's interference of its radius versus this interference of this radius create a charge buffer sort of thing. It's an average of an electromagnetic pulse network between all particles in the field. That at certain points there's going to be a pulse here and a pulse here and a pulse there and a pulse there, and it's all rotating, all going crazy. As you've seen in my photo of my curved interference pattern, that demonstrates that photons all interfere with one another. They behave as particles and waves, but they don't always create a consistent structure of that interference pattern without manipulation, without interference in general, right? So that's you can't have the interference pattern without interference. So when you're looking at how these bond together and they sort of average out, right? So there's going to be an electron build up here if they remained steady and constant. So these have to move away from one another. They balance out the distance between the nucleus, and the field grows. And this is, that's how magnetic fields work too. They only accumulate. They don't actually isolate one another, or you can't insulate a magnetic field. They just build. And so as your pulse charge interferes with the front, there is less quantum atmospheric density around the outer. So that charge pulses outwardly, builds up, and then this has a volume versus volume. And then it sort of creates voids, in a way, if you want to look at it like that, to pull towards one another. But I don't look at it like that. I see it as, yes, the voids could be pulling on the nucleus and the particle, but in space, the void only works to pull from either decompression or something like that. So these charges are actually pushing on the nucleus of the atom. It's not a warping in space-time. It's an accumulation of electron atmospheric pulses that average out at a contradictory point here to the center of mass. And I probably won't be able to get all this out every time I try to make one of these videos. I get really dizzy explaining it all. So the way I was trying to equate this is that volume divided by density and density divided by volume create two separate states of mass. And if you look at it like mass 1 and mass 2, and mass 1 divided by mass 2, you get no particle. You get a charge to null particle development. So then you need a fundamental value for what a null particle equals out to. And I was working on a new number theory and structure for this, and I figured it out. It's just I'm not a mathematician, and I'm not trained in physics. Anyway, trying to show all the different interferences and how these fields warp and visualize them and drawing them out. All matters takes the path of least resistance, right, as we all know. So then when you look at these, it's kind of like a void. That is your path of least resistance. And all this gets into why quantum physics is so improbable. Everybody's so confused about it. And it's not necessarily it's confusing, it's because I see everything for and against. So when I'm wrong and I think about something backwards, it's not hard for me to flip it around and be right if I'm wrong, and I don't. Anyway, so you can look at how particles come in and out in the field, and looking at sets of simplified variables for interference, probable paths, and this is all similar to Raman scattering. So I had no idea what Raman scattering was. I was just hanging out with some scientists on Twitch, and some of the guys in there like quantum physics, so we got talking, and they're like, "Oh, you're explaining Raman scattering," and so this is all the variables of particle interference that I could come up with. So you have your basic Feynman-like diagram. I think his has the electron and positron on both sides, right? But so there's your main interference with photon annihilation. Now, photon annihilation is a paradox. It doesn't make sense in that how can a black hole split the positron and the electron at the event horizon? And what is the expansion, the evaporation of a black hole, and why does it happen? Well, I'm going to get into that. I have an idea that I think explains it. As far as the gravity goes, I'm pretty sure I did my best to explain it. It's all in my fucking head. It's just hard to write out. So if anybody wants to read this, there you go. You can read it. And as far as I know, quantum atmospheres, quantum atomic density, and then subquantum physics are all my original ideas to explain gravity and why particles, nuclei, are pushed, not pulled. And then all these little things are just explaining, like, interference variables. And obviously, I think I missed... let's see here. This is the last page. This is the latest thing. So my number theory. I thought I wrote that up over here. I thought I write it. Anyway, in my earlier equation that I drew up years ago to explain relativistic and equivalence as two user variables, essentially, as time is a constant and time throughout space. And this sort of method, which accumulates down here into this, explains how matrices, it's sort of like a matrix. I just don't like matrices. And back to why black holes evaporate and my number theory. So this is pretty weird in contemporary math, I get it. So this was the fundamental value I was considering, in that if you look at it like my other equivalents and points here in how probability equates to null particle mass and subdivisional mass, you have 1,000.001. You can look at this like rationalizing an infinite number. So you take pi, you rationalize pi. What is the last digit of pi? Well, the last digit of pi is anything from 0 to 9. That's going to be the last number, right? The last number of pi. So we have a 1 in 10 variable potential. You have here an attempt to rationalize pi. So, and it does a little bit more than just that. So, as it says, 1 is a fundamental value, obviously. So the accumulations of 1s can add up in any direction to create your brain is collapsing. So another consideration is that gravity is a result of radiation. It is the opposite of radiation. An equal and opposite force. Gravity is the opposite of radiation. Anyway, I got into how that radiation between two particles creates a mass that has to expand outwardly, which creates pulses that then accumulate on the opposite perpendicular to center of mass, and that creates pushes rather than poles. And so cyclic cosmology. And I didn't get into explaining the other things I was going to fill this page with, but that's still in my head. So this is your limit to interference, and if you set that at pi 314, you can extend this center out as far as you want. You extend this out as far as you want, and this out as far as you want, and that allows you to look at this like 1.314 and 314.001, so that you're combining these numbers into a. Are you gonna render here? Mass 1. Oh, whoops. I didn't write the 2. My bad. So that one should be mass 2, I believe. Mass 1 times mass 2 equals 1.314.001. And okay, so what the hell is his name? Stephen Hawking. Thank you. Brain. He said that at the shell, the outermost part of a black hole is like these little hairs. And I was just like, well, what if it's a weave, actually? I mean, what if it's like a filter? A subquantum particulate state of filtering out, not just dividing and preventing photon annihilation, but the mass of the positron is actually divided, and it's creating a positron shell with an electron at the center, and these weaves are constructed from these positron shells that the electron is captured at the center of these positron shells, and the gravitational field pulse allows the electrons to, which is more like a subquantum electron state, because this explains how electrons don't bond with the nucleus. There are subquantum electrons in the nucleus of the quarks, and constructing quarks. And so if you look at it like a big weave, a shell of positrons, that these electrons then are pulled into the center, finally. That's where they've always wanted to be. That's why they're around the nucleus of the atom. That somehow they're getting there, and they're creating a infinite density. And there's no space inside of there. So a law of philosophy that I found. One of the only laws of philosophy is for something to exist, there must first be nothing for it to exist in. I don't know why on my phone that doesn't look like must, but it does. So then as the core of perfect density grows, it reaches a certain point where the positron layer starts pushing outwardly and evaporating. And Hawking would talk about black holes evaporate, and with cyclic cosmology, I just didn't understand like why that would happen. And the only thing I could conclude is that positrons are hollow. They are losing a majority of their mass, subdividing, going into a sub-quantum state where they house almost perfect vacuums, if you want to say that. It's like a perfect vacuum inside these little positrons that then interfere with other electrons. They capture them. So these little balls, these little orbitals, I don't know what you fucking call them, these sort of form the strings and the probability of string theory and stuff like that. To me, this explained fucking everything. So it just, this is how particles form, is that they expand at like, and it's interesting because they house almost a perfect vacuum, yet they expand at a perfect density, sort of like evaporation. This increases the probability of a free electron to be captured at the center of this positron. And this is like positron shell. And I don't have all the words, like it's hard to explain it all. And so as matter starts to interfere, you end up with this idea that photons can actually share their cores, in that a photon is essentially this vibrating core in here, this electron wanting to be pulled towards the positron outer, and that as they travel they can exchange. And this is how I explained quantum entanglement, and I was going to get into explaining the evaporation field and increased probability of capturing electrons to initiate then the construction of matter, that these then start behaving oddly. Essentially, you know, they push and pull, they do really funny things, and once in a while then a neutral particle substance, it's a neutrino is just, we say they don't have a charge, but really the charge is so small that when it interferes with other fields, it pretends like it's not interfering. But we wouldn't be able to detect them otherwise. If they were truly neutral, nothing would happen. And so it's just 25 minutes long. It's so hard to just get all this out. This is why I've been trying to write it out a little bit at a time. And not being trained in physics means that I don't have all the words. One thing I never liked was people would name theories after themselves, so I can't interpret that theory to learn something, so I have to figure it out myself. And then, like, when you say warping a space-time, well, I don't even know what the fuck that means. Now I do, because now I know how we measure time and movement and everything. But but it didn't make sense at this time. So I tried to write a comprehensive, simple solution to this to explain gravity and why anything happens. And so, if I'm right, this is a new state of matter. And it would explain why black holes have an infinite density at their core, why they have hairs, why they evaporate, and how particles form after. And you can look at it like an antiparticle, but I don't look at it like antimatter. I think antimatter is more like an electron field having a positron charge, so it's just a bunch of positrons. And would this imply then that positrons and electrons, what is the difference? Well, I see electrons as having an infinite density, and that explains why they're so small. They're tiny little thingies, and that's why they can create quantum atmospheres that create quantum density, that in turn fundamentalize this law of philosophy, and everything else I've kind of tried to go over. I don't know if I'm forgetting anything. Especially since I've found out recently I'm dyslexic. Which I knew I was always partially dyslexic, but I've been noticing more and more and more lately. And how I read something and the words will be flipped or certain letters. And I think that goes into having a partial eideticism. I can highlight certain things with my vision. I can construct things, imagine them, pull things off the page if I want to. It's a lot you can do with it when you're dreaming or when you're laying in bed is when I've been trying to control it better. To be more like what Tesla had, but I can't get that to that level. I don't know if it's possible. I'm getting close. Super close. But I can't control it. It just randomizes. It starts just doing all sorts of crazy, uncontrollable things. And that's probably why I'm dyslexic. So, that is off topic. Okay. Now, what else is there? Is there anything else? I don't think so. No, other than why we have a speed limit. I mean, I think I went over that when I mentioned colored glass condensate in another video, of how traveling at the speed of light means that the electrons in a field, everything's traveling at the same rate, so nothing can travel past this point here. And then it sort of equalizes, evaporates, spreads out, and then everything just turns into what Einstein called colored glass condensate. And it doesn't matter, I'm pretty sure, no matter how you contain particles as you approach the speed of light, they say time slows down. I don't believe that. To me, it's yes. So, as you approach the speed of light, what we consider time is your charge from one side to another and in space. So basically everything evaporates at the speed of light. It just falls apart. Matter just falls apart. But it's impossible to get to that point, so... Well, unless you just, like, have an atom bomb go off. That's kind of close. Cyclic cosmology. That goes back into... I was thinking about quantum atmospheres before Roger Penrose. I even knew who he was. And into an interesting concept of me. We don't have to get into philosophy. I think it's pointless for this. But I am a fan of cyclic cosmology. I thought the universe would cycle endlessly before he won his Nobel. But he wrote that theory a long time ago, right? So I would never pretend to claim it. No way I could. There's no way you can prove that you thought something without learning when it's already public information. So this is how I am trying to gain my viability, to say, as a natural thinker. And that this is how I see reality. This is what it is to me. This is everything I look at, this is what it is. And through this number theory, we can set limits to pi so that we can fundamentally, get a grasp on things. This leads to knowing is what it is. It's so you can set your limit to interference at however many decimal places. Say you want 1 trillion decimal places, or if you want to have 314, I would say 314 decimal places thereafter versus 413 in this direction. And there's other ways to work it out if you want to try doing that, if anybody actually wants to take this seriously other than me. That well, I just want the credit for explaining gravity and how particles can form after expansions of a black hole. And that anyway, it sets the fundamental values. And I don't know all the math going in talking work or cyclic cosmology, so whether or not this correlates or not, who knows for me. I mean, somebody will come up and be like, oh, that's that theory, that's that theory, that one's a different theory, that one's somebody else's theory. Hey, thanks, dude. Cool. This is why I don't learn other people's stuff. So I don't feel like, one, I'm not stealing other people's work, and two, so I can know that, I did it on my own. And we're always guided. All lesson plans are guided. But we teach you ways to think, how to organize words. We teach people how to do math, how to organize letters and numbers and create variables. And I need a drink. My throat is super dry. Oh man, I don't have a soda. Craziest thing, I left a Sierra Mist in the freezer all night and it didn't freeze. I have no idea how that happened. So as you can see, I was trying to equate null to 1, and then if you do the math based on contemporary charge on the periodic table of, say, hydrogen, you can get a limit to how many null particles are within a hydrogen atom. And that sets a sort of limit to how many null particles and these subquantum particles go into different quarks, different charge limits, to set variables to explain why we have push and pull and how two atoms interfere with one another, why they can compress closer, they can expand outwardly, they can reach critical mass and explode apart. And see, I'm going to talk as long as I can until I know I've gotten every little thing out. Since this is my pride and joy, I've spent a lot of time working on quantum atmospheres, trying to figure it out. and some sub-quantum physics. So, like I said, I don't know if we could ever prove that there is a positron shell that I'm talking about, where positrons divide and particle annihilation is solved. There's no more paradox there. And this explains how, back to entanglement, right? How because contemporarily we believe that when you look at the double slit, that a photon is traveling through both slits at the same time. Well, I tried my best to sort of draw that out too, which is similar there as well. And a really old drawing I did way back here, when I was trying to understand what the hell a photon even is. And how a positron is emitted from the nucleus of an atom that attracts or captures a electron. And whether or not I'm right, it's just, this is how I see reality. I can't change. So all dice are in, you know. This is it for me. You can see my drawings if you want. My scribbles of the Monet exhibit. Man, that room was cool. The lily pads, that was just the greatest room I think I've ever been in my entire life. I didn't want it to end. I wanted to be stuck in a Twilight Zone episode, just stuck in that room. And there was another room. God, those paintings were good. How the hell do you draw Monet? And there's the first lily pad. Oh, it was beautiful. I'm just having fun. It was so good. 125 Monets in one exhibit. Next to Van Gogh, he's my favorite painter. And my favorite modern artist is Chuck Close, which is who I developed those styles after. Inspired by Chuck Close. Some days I hate that one, other days I love it, but I've spent years working on it. Every layer, every blend, every little texture. I don't even paint on it anymore. It's just needs to be done. And my sunflowers. Love that flower. That one came out great, right? The other ones are... It's just like, I was trying variables, different ways. How could I paint different flowers in different methods? And normally my paintings take weeks and months to finish. This one I did in like 2 or 3 days. I was trying to see if I could make something that I liked quickly. Always helps me to go off topic a little bit so my brain can regather the information and organize it again and see if there's something I missed. I think I covered it all. And this is like a little gap in physics that once you start expanding beyond this, it's other theories that are all contemporary and well regarded. I've never been a fan of string theory, though this kind of helps to explain string theory in a way. It's really odd. There's parts that are incorporated in it, but when I was writing it, I was like, oh man. That's that other thing. And that other thing. And that other thing. Another is that I didn't want to have straight lines in trigonometry and calculus. I don't like the idea of straight lines used to calculate curves. It's a ridiculous idea to me. So I was thinking how you can calculate the length of a curve using radiuses, that then you use the calculated circumference of that radius to create no different than an infinite amount of triangles, an infinite amount of radiuses and curves at specific circumference lengths to create curves. And that's another thing. Other than that, nobody's gonna watch this anyway. I could have made it shorter, right? I tried to talk as quickly as possible. But that's gravity. It's not a warping of space-time. It's an accumulation of electromagnetic pulses in the quantum atmosphere that manipulate subquantum densities and atmospheric densities to pulse and create either, if you want to say, a vacuum on one side, but it's really a lesser charge, since we know there can't be a perfect vacuum, that these electromagnetic field impulses accumulate on one side opposite to interfering particles and pull and bond them together, and it is essentially the opposite of radiation. Cause and effect of radiation. But radiation's a little bit quicker than that, isn't it? It's just that the charge of the null particle mass of a radiative field at its velocity is so small that it accumulates at the various radii away from the nucleus of an atom. Thanks for watching. I'm gonna go grill some burgers and wait to die.